So for project 2, I'm going to do an example from the homework, which is how to get the depth of a fish that's in a tank with a mirror at the very bottom. This is a prime example of Snell's law, which is the relationship between refraction and incidence. A tank whose bottom is a mirror with water to a depth of 20.5 centimeters. A small fish floats at 7.30 centimeters under the surface of the water. The first question is, what is the apparent depth of the fish when viewed at normal incidence to the water? It said the index of refraction would be 1.33. This is the equation that we're going to use. Okay, so 1 divided by 1.33, which is the index of refraction we talked about, times 7.30 centimeters, which is how far under the fish was from the surface, equals 5.49 centimeters, which is the apparent depth of the fish. Alright, on to part B. It asks, what is the apparent depth of the reflection of the fish in the bottom of the tank when viewed at normal incidence? And again, we're going to use the index of refraction at 1.33. Now we're going to go in with the same equation we used last time. We're just going to use this number for d sub 1. So we're going to do 1.00 over 1.33 times 33.7. Okay, the final answer is 25.34 centimeters, which is the apparent depth of the reflection of the fish in the bottom of the tank.
Together, diffraction and interference help explain the results of the famous double-slit experiment conducted by English physicist Thomas Young in 1801. Young covered a window so that only a very narrow stream of sunlight passed through a slit into the room. Then he positioned a plate with 2 more tiny slits cut into it, spaced very close together, so that the single beam of sunlight passed through them. Finally, he placed a screen behind the slits. If light were just a stream of particles, you'd expect to see 2 bright lines on the screen behind the 2 slits. But that's not what Young saw. His screen had many lines on it. There was a bright line in the middle, then more bright lines above and below it. This pattern is called a diffraction pattern, and it comes from the diffraction and interference of light waves. Light waves interfere constructively when they're lined up exactly right. For example,